Okay, so this is the graph that we're going to be looking at, and we're going to look at a couple different scenarios of a walk and try to determine if it's a trail, a path, a closed walk, a circuit, or a simple circuit. Okay. So, a little off the screen, but do I go all the way down there? Okay. So let's say, why don't you write that one down? V naught, E1, V1, E10, V5, E9, V2, E2, V1. All right, so this is going to be a walk. And now let's look at what our walk is doing. Okay, V naught is taking E1 over to V1. V1 is taking E10 down to, well, okay, you can't really say that. V5, okay? And then from V5, we're going up to E9, up E9 to V2. So from E9 to V2, we're at up V2, then E2 is going to map over back to V1. Okay, so what is this thing doing? It's going da, 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 and then okay, V1, then V1 to E10, to V5, to E9, to V2, and then E2 is mapping over to V1. Okay. Now, just from the statements, E1, E10, E9, E2. Okay, so now a trail from V to W is a walk with no repeated edges. Well, if I look at my edges, E1, E2, 10, E9, E2, I didn't use an edge, okay? So that is a trail. Okay. Okay, do y'all think this would be a path? And remember, the definition of a path is that a path is a walk from V to W with no repeated vertices. It is not a path. Why is it not a path?
Because you use the verse C1 twice.
We use V1 twice. So since V1 is repeated twice in here, this is not a path. Okay? And then the next question that you can ask is, all right, is it a trail? Is it a path? Is it closed? Okay? After asking if it's closed, then you can ask if it's a circuit or a simple circuit. So is this path closed? Or trail, sorry, not path. Sorry, the words are interchangeable in English versus math. So do I end where I began? No, and it's not closed. Hence, I can say it's not closed, it's not, and since it's not closed, it's not a circuit. And if it's not a circuit, then it can't be a simple circuit. Those are stronger conditions that go with that. Okay. Let's say we did V4, V7, V2, E9, V5, E10, V1, E3, V2, E9, V5. That's a long walk. All right, now without even looking at the graph, let's just look at this statement right here. Ask ourselves, first, let's ask ourselves, is this a trail? And a trail would mean that there are no repeated edges.
Yes, that's true.
But wait, no, yeah, because we have E9 and E9. It's going to hit E9, that edge twice. So, and trail says no repeated edges. So, trail is out. Is this a path?
No,
Why would this not be a path?
because it's very steep.
Which ones?
V2 and V5.
V2 and V5. So this is not a path. Is it closed, just from looking at that?
No.
No, and it's not closed. That's just a walk. Okay, let's try another one. And see, now on this one, I'm gonna write it not as a sequence of vertices and edges, just as a sequence of vertices. And let's first see if we can actually determine if this makes sense. And I'm gonna put this one just like right up. Well, no, I'll put it on this page. See if I can squeeze it in somewhere. Let's say, oh, y'all can't see that. Actually, let me squeeze it in right here. Because you really need to actually be able to see the graph of this one for this one to make any. So V5, V2, V3, V4, V4, V5. Okay, so what would this path look like? See, the reason that there's some ambiguity whenever you talk about not incorporating edges, if I said from V1 to V2, I don't know which edge I'm picking. Okay, but on this one, if I say from V5 to V2, there's only one edge. So there's only one way to get from V5 to V2. So I'm going from V5 all the way to V2, and then I'm saying, okay, from there I'm gonna take V2, and I'm gonna go to V3. Okay, great. And then from there I'm gonna go to from V3 to V4. Well, how do I get from V4 to V4? That would be this loop right here, and then V4 would map over back to V5. Okay. So there's no ambiguity about how we're going to actually achieve this. So what's the first thing that you could say about this? Hmm? Oh yeah, they're all lots.
It's closed.
It's closed. That would be the first thing that I would look at in looking at this problem, is it closed? Okay. Now, we actually had to walk along that thing to see where, so let's look at this again. We know it's closed because we get back to where we started, and let's see how we got there. We went from V5 to V2 to V3 to V4. We looped back around, and we went back to that point right there. Okay, did we repeat any edge while doing this? Went bam, 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 looped around, and we went back to where we started. So no repeated edges, okay? And if we look at our definition, okay, A closed walk is a walk that starts and ends at the same vertex. Okay, we already determined it was closed. Okay, a circuit is a closed walk that contains at least one edge and does not contain any repeated edges. So since this does not contain any repeated edges, it is a circuit. Okay. And then our next definition, normally when I do this, I start at closed and then figure out these, and then we can go back and look at trail and path. I consider these more important. Okay, a simple circuit is a circuit that does not have any repeated vertices except for the first and the last one. Well, this is represented right here. We end up hitting V4 twice, okay? So because we ended up hitting V4 twice, simple as that, okay? And then if we were just talking about trails versus paths, a trail has no repeated edges. Great. A path has no repeated vertices. Okay. And you might think there could be some type of analogy in here between circuits and a simple circuit and a trail and a path. Not really. I mean, there is kind of, when you say a trail has no repeated edges. And then a path just has no repeated vertices. A simple circuit would have no repeated vertices and no repeated edges, because it's a higher condition than just a circuit. Okay? Okay. That'll make it decent, I do.